We often talk about the climate crisis, natural disasters, and an uncertain future, but we rarely ask a more fundamental question. What system has been absorbing all the impact of this time? The answer is right in front of us and beneath us, the ocean. The ocean covers more than two-thirds of Earth's surface. It is often perceived as a passive space, vast, calm, simply receiving change. But in reality, the ocean is an active system, constantly working to stabilize our planet. Physically and chemically, the ocean is the largest buffer in the Earth system. More than 90% of excess heat generated by global warming is absorbed by the ocean, not the atmosphere. Without this heat uptake, air temperature would rise far more rapidly and dramatically. The ocean also absorbs a significant fraction of the carbon dioxide we emit, slowing the pace of climate change. And nearly half of the oxygen we breathe is produced by marine photosynthetic organisms. This means that climate stability, oxygen availability, and global food system all depend on healthy functioning ocean. The ocean is not supplement to modern life, it is its foundation. The role of the ocean does not stop at the surface. At the seafloor, the layers of sediment accumulate gradually year by year, century by century, and in some cases over tens of thousands years. Each layer forms under specific environmental conditions and record them physically. Water temperature, biological productivity, change in ocean circulation, and even extreme events such as large earthquakes, submarine landslides, and tsunamis. These records are not metaphorical, they are measurable. Using quantitative dating methods, for example, radioactive isotopes that preserve in microscopic marine organisms or volcanic ash layers with known eruption ages, we can determine when each sediment layer was formed. In this way, marine sediments allow us to reconstruct a precise chronology of natural events with a time resolution that instrumental records alone cannot provide. Why does this matter? Because many of the most devastating natural disasters are rare but catastrophic when they occur. Human observational records span only decades to at best few centuries. That is not long enough to understand the full behavior of Earth systems. Marine sediments extend our memory. From them, we can learn a lot of things. For example, how often megatrust earthquakes have occurred, how large past tsunamis were and how far they propagated, and how ocean circulation and climate responded to extreme temperature change in the past. This information fits directly into disaster mitigation efforts such as coastal hazards mapping, spatial planning, and the development for reliable climate models. In short, we use the past to reduce risks in the future. However, the system has limits. When marine ecosystem and sediments are disturbed by pollution, hypoxia, acidification, or physical disruption, the reliability of climate and hazards records degrades. At the same time, the ocean's capacity to absorb heat and carbon weakens. We lose two things at once. The first one is our ability to read the past, the second one is our ability to buffer the future. It's important to recognize this turning point. When environmental change occurs faster than ocean system can adapt, risk increases significantly. Today, the rate of change is driven not by long-term processes but by human activity. Protecting ocean is not merely an environmental issue. It is directly linked to climate stability, disaster risk reduction, and our capacity to understand how the Earth system works. When the ocean function is compromised both as a climate regulator and as an archive of past change, uncertainty about the future grows. In this context, protecting the ocean means protecting the resilience of systems that have supported human civilization all along. The ocean has preserved Earth's memory for thousands of years. The question is not now whether the ocean can endure. The question is, are we wise enough to protect the system that has been protecting us? Thank you.